Hey guys, today we'll be going over my program I've done in Rust to make a Connect 4 game. To start off, I'll show you how it works and what the product is. So to get it to go, first of all, you need to have an extension installed in Visual Studio Code called Rust, I believe that's all it's called. And you have to go to your terminal and hit cargo run. So when you're there, you can see I had fun creating an ASCII board for a Connect 4 game. And we can see we can just drop in random slots and when we get a winner, so we can see O's have 4 in a row. It says O's win and the program stops. So yeah, that's what the game does. It drops pieces in as the rules of Connect 4 work, and it detects a winner and exits out. And there's another test example I can show you. If the board fills up, forgive me, it takes some time to fill it up without having a winner. But in my debugging process, I discovered this route. So when the whole board is filled and there's no winner, on the next drop, it'll say draw, and the program exits out. So those are the two ways that the game can end, either a draw or a win. So Rust was really fun. There's mutable variables and there's immutable variables. By default, they're immutable, but as you can see, I use mutable quite a bit to let the variables change. I used a lot of passing things by reference in this program. For example, I created a multi-dimensional array here. I called it the game array, and then I passed it here to display board. So it displays the game, or displays the board, as you can see. First thing it does is displays the empty board. And we go to display board, and it's just a couple loops that display some ASCII stuff. But right here, this is what's important. We can see that the game array is getting dropped in at every position inside our board. And so to start things off, our game array is going to have nothing in it except for spaces, just one space character. And then when something gets updated, that space character gets updated either to an X or to an O. That way it looks like it's just dropping an X or an O in here, but really it's just a space being replaced with an X or an O. But anyways, so that's how the game gets updated. Most of the code, as we just passed by, was win conditions. I guess we can go over that. So to win vertically, there's only one way, and if the final piece gets dropped and there's 3 underneath it. So we just need to check if the piece is dropped, if the 3 underneath it are like the same symbol as the top one, then they win. But for all the other cases, there's horizontal cases, there's northwest, southeast diagonal, and there is southwest to northeast diagonal cases. So for all of those cases, there's 4 conditionals. If there's the rightmost chip, the second to left chip, the second to right chip, and the leftmost chip. So that means, like, for example, if we have, let me annotate here. If we have an O, and an O, this is the leftmost chip winning. But that's not the only case. What if we have an O like this, and we drop it in right here? This is a case where the second left chip wins, and so on with this one and with the rightmost. And the same goes for the diagonal, right? It depends which one is dropped in. This one, this one, this one, this one. So for each one that can win the game, we're going to be checking for that condition. Above that, there's ask user. What this does is it gets input from the user, which was kind of a pain in Rust. It gets input from the user, and it has to be a string as the input. From there, we convert it to a usize, which is what's used to look through arrays and index through arrays. And from there, if it's not a usize, meaning it's not an integer, then it'll say this was not an integer. And from there, this is an else statement. So match is like a switch statement. And so it's saying we're going to get this input text and we're going to convert it to an integer. If it's not an integer and there's an error, it'll tell us it's not an integer. If it is, then we're going to create a new variable, and we're going to create a usize because we know it is an integer and there will be no problems. And then we create another match statement. If it's between 1 and 8, which are our columns, then we're good. Then we just drop it in at that value and we add it to our game array. That's what drop in value slot, drop in available slot does. It adds it to our game array. And if the value they punch in is not 1 through 8, then we say that's not a valid slot and we make them do it again. Let's see what else is important. So this is our drop in available slot. This is a important function. So we can see we do for I in 0 to 6, and this means inclusive in Rust. If it's like this, that means exclusive. So that's kind of cool. And then if we do dot reverse, that means we go from 6, 5, 4, 3, 2, 1, 0 instead of obviously the other way around. In this case, because it's a U size means unsigned integer. And because of that, we can't go to -1. So it was kind of funky how I had to do this. I had to do 0 through 6 instead of 0 through 5. We can see 0, 1, 2, 3, 4, 5 rows. So everything we did, we checked if it was 1 through 6, and then we just minus 1. And then we said if it's 0, meaning that all of the rows are filled and it's at the 0th column right here, then we just tell it this column is full and we ask them to do it again. And then this right here, it checks if all of them are full. If they're all full on the top row, then the next one they do, it's going to say draw and it's going to exit the game. Symbols, obviously get symbol. If it's an odd turn, then it's X. If it's an even turn, then it's O's. Player 1 and player 2. And that's pretty much it. It took some time to figure out the syntax of Rust and passing in stuff with by reference, mutable, immutable. The hardest thing was probably these match statements alongside getting input from the user. Also, another hard thing was getting started. I had to get to the command prompt window and start it there and then convert it all into Visual Studio Code. But Rust was awesome. One thing I wanted to show off is some of the error messages with Rust. Like, let's say, for example, this isn't mutable and we try to run it. It'll say error and it says, check it out. It says right here, when we're trying to do this, it says help, consider changing this to be mutable, a mutable game array, which is really, really helpful debugging error codes. And obviously if we do it, it works. And we can see if we just type in random stuff, eventually we'll find a winner. There it is. Bam, 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 bam. So it works and it works well. This was pretty fun. It was really fun to think about how to come up with checking if it's a win. Initially, I thought after every turn, check the entire board to see if it's a win, but then I got an idea from a classmate that we should be checking only after every time someone drops. So they drop, and every time they drop, then we check. And we're not checking the whole board, we're just checking where he dropped, or she, and the adjacent symbols. Let's say, is this one, is this one, or is this one, is this one, is this one, is this one? Are these like? No, no, but this one is. So then we check in that same row, and it's a lot more efficient doing it that way than to check the board every single drop. But yeah, this was really fun. Thanks for watching.